Find h inverse of x if h of x is given by this formula here. 2 to the x plus 5 over 3 minus 2x. Okay, so find h inverse. They're not saying find h inverse if possible. Tell me if it is invertible. No, the way the question is worded, we should expect an inverse. So we're just going to jump straight into, well, how in the world do you calculate a formula for an inverse function? And so the way you do that, you start with y equals your expression in terms of x, and then you swap the x's and the y's. So we'll get x equals 2 to the y plus 5 over 3 minus 2 to the y. And what we want to do is use algebra and other approaches to isolate y all by itself. Now, the first thing I notice, we have two y's. We need to have only one y by the time we're done. So it'd be really nice if we could find a way to get these y's together. Well, one of them's up on top, and it's in an exponent. The other one is down on the bottom in an exponent. And the easiest thing to do would be to multiply both sides by 3 minus 2y. Or sorry, 2 to the y. Okay. Why that? Why doing that? Because that brings it up here, so now it's at the same level as sort of this other 2 to the y. So now they're both in the numerator, or both on top, and the y's are both in exponents. So we can probably find a way to deal with this. Let's expand out here. 3x minus 2 to the yx. And now, well, we can't get the y's together, but we can get the 2 to the y's together pretty easily. We're gonna subtract 5 from both sides, and we're gonna add the 2yx to both sides. Because now what I can do is I can take out a factor of 2y. And now I went from 2 copies of y to just 1. Factoring things out is a great trick for that. If you have multiple of the variable you're trying to solve for, it doesn't have to be with functions, it could just be in general with algebra. A good way to get is to group them all on one side and factor them out, because that reduces how many of them there are. Okay, so we got 3x minus 5, and then ignore the middle bit for a moment, is equal to 2 to the y times 1 plus x. Well, I would like to just solve for y, so let's divide both sides by 1 plus x. So we'll get 3x minus 5 over 1 plus x, and that'll leave us with just 2 to the y over here. Oh, we're almost there. There's y, but there's this pesky base of 2 in the way. How do you get rid of a base of 2? The log base 2, the logarithm of 2, the inverse function there. So if we log base 2 both sides, I'll move it over here. So log base 2, because you got to do whatever you do on one side, you got to do on the other. Otherwise, you're not allowed to keep the equal sign. It equals log base 2 of 2 to the y, but log base 2 and 2 cancel out. That's why we chose to do log base 2, so we have y. So we've isolated for y. That means whatever's left over here must be the formula for the inverse, which we're running out of space. I'm gonna put it way up here. So here's the formula for the inverse. Log base 2, 3x minus 5 over 1 plus x. There it is. There is our final answer in all its glory.